Okay, so in this problem, we're trying to find the area of the trapezoid ABCD, and you can outline that here. See A to B, right, to C to D. And the basic application that we're going for here is recognizing how to use the formula or understand how to use the formula in order to find the area of the shape. And the formula for area, right, of a trapezoid, and we'll go over why this makes sense in a moment, is written as usually base 1 plus base 2, right, over 2 times the height. I often see it like this. However, dividing by 2, of course, can be thought of as halving or multiplying by a half. And when you're multiplying by a half, you have flexibility, so you can rewrite this in different ways. Base 1 plus base 2, right, times the height, all of it over 2. Or you can think of it as base 1 plus base 2 times h over 2. These are all different ways of thinking about it. You can even distribute the h to get hb1 plus hb2 all over 2. That also works. These are just different ways of writing the same exact formula. But here, we're given everything we need actually, because we can think of 20, let's say, as base 1, and we can think of 15 as base 2. And we can reverse that. It's commutable because we're adding those two, and that order can be reversed. And 5 is actually equal to the height. Now, what's important to recognize is that you only have a height here because of the right angle, right? It crosses at a 90-degree angle, so it's a vertical line. And essentially now we can plug into the formula and say, oh, well, then we have 20, right, base 1, plus base 2, 15, right, multiplied by the height, which is 5, all over 2. So this is going to equal what? Well, 20 and 15 is 35, times 5, well, that's 150 plus 25, or 175, over 2. And you can see now that all we have to do now is take 175 and cut that in half. So 80 times 2 is 160, another 15 or to go, or 7.52, so that's 87.5. That's the area of our trapezoid. Now, the basic logic here with the trapezoid is that you can think of a trapezoid being doubled, right? And when you do that, what you get is a parallelogram. So in this case, do a rough sketch of this trapezoid, something like this. If we double this shape and kind of flip it upside down, so it's the exact same shape, just tiled a little bit differently, right? What happens is we form this new shape, which is, of course, is a parallelogram. And parallelograms run on the idea that the base times the height is the area. So here we have these vertical lines, and that means that is the height. So here's our height right here, right? So to find the area of this parallelogram, we would multiply the base by the height, and we would be done. Except here, remember, we called this base 2. So base 2 is now down here. And we called this first chunk right here, that's equal to base 1. But that moved up here. So if we were to say in this parallelogram that base 1, that the base times the height is equal to the parallelogram, here we could say, oh, well, this base is really base 1 plus base 2. That's the full length. That's the full base. So here we would say base 1 plus base 2 times the height, and that's this whole parallelogram, but we wanted just a trapezoid, of course. And the trapezoid, you remember, is half of the total shape, right? So we don't need just base 1 plus base 2 times height. That would give you the whole parallelogram. We cut that in half to get the trapezoid we need. That's the way I break it down conceptually. All right, hope this helped.